Hey, what's up, pre-calc students? The last lesson in chapter 1 is about inverse functions and relations. So two relations are inverses of each other if and only if for each x comma y on one of them, the other contains the point y comma x. So in other words, inverse means switch x with y. And that's all you got to do to come up with what's called the companion point. Okay, so problem number 1 says the table shows some values of the relation y equals x squared plus 1. So if you plug these 5 x's into the equation, you'll get these 5 y's. Plot them, connect, and you get a parabola. And what we want to do is graph its inverse relation. So if you can see, we started with the equation y equals x squared plus 1. Inverse means switch the x with the y, so the inverse relation would look like this as an equation. Now I'm not going to get the y alone in that new equation. I'm going to leave it like this. And what we're going to do is just complete the table of values for the inverse by simply switching the x with the y. So if negative 2 comma 5 is on the original graph, you can bet your bippy that 5 negative 2 is on the inverse graph. So why don't you pause the video, complete this table, plot the points, connect them, and then we'll answer the next set of questions. Alrighty, welcome back everybody. So hopefully you came up with that graph as the inverse relation. I added in this line y equals x, mainly because when you switch the x and y to get your new equation, the graph you get is just a reflection of the one you started with over that line y equals x. So if you want, just tilt your paper so that red line's vertical. Or I guess you could leave the paper alone and tilt your head. But now you can see the symmetry action going on. So that would be true for all inverse relations. Y equals x is their line of symmetry. Okay. Question B, is y equals x squared plus 1 a function? So if we look at the graph we started with, that certainly passes the vertical line test. So we want to be specific. So let's say yes, because that graph passes the VLT. So if I ask you, is that graph that we just talked about a one-to-one function, why or why not? Well, if we come down here, we can actually fill this in first and come back. It would have to pass something called the horizontal line test. So any function that passes the horizontal line test is said to be a one-to-one function. So that means every x value matches with exactly one y, and every y matches with exactly one x. So when you look at the table, the problem is the y value of 5 is paired up with 2 different x's. So for that reason, this graph would fail the horizontal line test. All right, so this graph, y equals x squared plus 1, would not be a one-to-one function because it fails the horizontal line test. All right, now we're asking about the other graph. Is the inverse relation x equals y squared plus 1 a function? Explain. Well, there's 2 ways we can answer it. One, we could look at the thing we graphed and just do the vertical line test to it. So we're going to say no, because this graph fails the VLT. Now, in most cases, you're not going to want to take the time to graph the inverse. So you can actually figure this out from the original graph by applying the horizontal line test. So what I mean by that is, if this graph fails the HLT, automatically, when you make its inverse graph, it'll fail the VLT. So we could say another way to answer this would be simply to say that that guy's not a function because, and write this equation down please, this graph fails the HLT. So you got to be precise which test you're using and which graph you're using the test on. So just be very clear when you respond to the questions. All right, so now some symbols for inverse functions. The symbol that represents the inverse of a function is the f with the little -1. So we'll read that as f inverse, the inverse of function f. Inverse functions are reflections of each other over the line y equals x. We can see that up there. We already talked about one-to-one. A function has an inverse function if and only if it passes the horizontal line test. So all that simply means is when this one passes the HLT, its inverse will be a function. So you can always apply the HLT test to the original one to gather information about the inverse graph. All right. And since x and y switch to make inverses happen, the domain of f is always equal to the range of f inverse, I should say. And the range of f is going to be equal to the domain of f inverse. So you'll see how that works as we go along. All right, so the next chunk, I'm giving you guys 3 functions, and we're going to try to just visualize what they look like and determine if their inverse would be a function or not. So when you see the absolute value bars, you got to think V. We got a shift of 2 units down. So I'm just going to make a very rough sketch and say, all right, well, if that's what that graph looks like, it's certainly going to fail the horizontal line test. So we could write our answer as follows. F fails the HLT. So f inverse is not a function. So we can safely say that's a true statement without even seeing the graph of the inverse because this fails the horizontal line test. All right, next up we got 2x cubed. So that's just a vertical expansion by 2 of our parent function, x cubed. So we got that point there. We come up to 2, down to -2. We'll sketch it. We can see that this graph would pass the horizontal line test. So what does that mean? The graph of f passes the HLT. So f inverse is a function automatically. All right, now the last one, it's quadratic, but it's probably easier to sketch the graph if you put it in factored form. So let's just realize that when you factor this, you get x minus 3 times x minus 3. So you can write it that way. So now that we have it in this form, we can tell it's just a shift of 3 units to the right of our quadratic function. So if you want to sketch it, we're going to take that vertex, go 3 to the right. Parabola is going to be over here with the 1, 3, 5 pattern, but we don't have to get that detailed. So now that we've graphed this correctly, we can tell it fails the HLT. So for that reason, its inverse is not a function. So just write the graph I gave you, or the function I gave you, fails the HLT. So its inverse is not a function. All right. All right, everybody. The last thing I'm going to go over in this video is just problem number 5. So it's just a little chart to get you used to the notation for inverse and whatnot. So in function notation, if you ever see f of 2 equals 8, that means on the graph of f, you'd want to plot the point 2, 8. That point would be on the graph. So if we're talking about the inverse, an inverse means switch x with y. We just have to turn the x and y around to create the inverse ordered pair. So if I want to use the function inverse for the function notation for the inverse, I could just simply write f inverse of 8 has to equal 2. So I'd like you to pause the video and see if you can fill in all the boxes for the rest of this chart, and we'll check it out in a second. Okay, welcome back, everybody. Let's take a look. So feel free to pause the video and look at what I wrote, but hopefully you're able to fill that in correctly and just bring this packet to our next class, and we'll wrap it up then. I will talk to you guys later. Toodles.